Dear friends, in today's video we are going to see a very interesting topic that I am confident that you all would be aware of. E. Okay, like pi, there is a constant called E, and how it comes, how we are defining it, and how can one tell that E, what will be the range of the values between which E lies. So, let us start the discussion. Can you find the limit of this term 1 plus 1 upon n raised to the power n, where n is a real number, n belongs to R, and given that limit n tends to infinity, you need to find it. Okay. So, from here we are going to define a series as E. Now see, as n tends to infinity, 1 upon n will be less than 1, obviously, because n is growing way large. Then I can apply binomial theorem, and from binomial theorem I can write nc0 1 raised to the power n and 1 upon n raised to the power 0. Then again I can write nc1 and 1 upon n raised to the power 1. Right, I am not repeating 1 raised to the power because it is redundant. nc2 1 upon n square plus nc3 1 upon n cube, like this. Okay. Now this will give you 1, this will give you 1. If you will simplify, you can see that it is nothing but 1, and this term will give you n into n minus 1 upon n square into 1 upon 2 factorial. Okay. You may do all the calculations and you will see n into n minus 1 into n minus 2 upon n cube into 1 upon 3 factorial. Now, if you simplify it a bit further, you will get from here 1 minus 1 upon n. Okay, 1n and 1n gets cancelled into 1 upon 2 factorial plus 1 minus 1 by n, 1 minus 2 by n into 1 upon 3 factorial plus dot dot dot. Now, if you put limit n tends to infinity, then 1 upon n will be 0. So, you will get 1 plus 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon 4 factorial till infinity. Okay, and this series we tell it as E, we refer to it as E. Okay, so this series is referred to as E. Now from this series you can easily see that 1 plus 1, that means 2, and 2 plus a positive quantity, that means it will be greater than 2. Therefore, we can conclude that E is greater than 2. But there will be we need to find a quantity from which E is lesser than, that means a upper bound we need to find on the value of E. So, how we are going to find the upper bound? We are, before finding the upper bound, let me discuss something, that 1 upon 2 factorial is equal to 1 upon 2 raised to the power 1. Okay. Now, if I say that 1 upon 3 factorial and 1 upon 2 square, which is greater, this is 1 upon 6 and this is 1 upon 4, that means this is greater. Now, if I write 1 upon 4 factorial and 1 upon 2 power 3, so which will be greater? This is greater. Similarly, it will go on. Now if what was the original series? That was 1 upon 1 plus 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon 4 factorial till infinity. This was E. Okay. Now can I say that this will be smaller than 2 ones are there? So I will be writing 2 ones, 1 plus, and in place of 1 upon 2 factorial I can write 1 upon 2 itself. Okay, no problem. Then 1 upon 3 factorial, I am going to write a greater term, 1 upon 2 square. Okay, 1 upon 2 square is greater than 1 upon 2 factorial. In place of 1 upon 2 factorial, I wrote 1 upon 2. I am writing 1 upon 2 square in place of 1 upon 3 factorial. Okay. Now in place of 1 upon 4 factorial, I am writing 1 upon 2 cube like this. Now this was nothing but this was E. Okay, this was nothing but this was E. So I can write that E is less than this particular sequence. Now what is this? 1 plus 1 by 2 plus till infinity. This is a geometric sequence, infinite geometric sequence. So I think that you would be knowing how to sum it. So A upon 1 minus R. So from here I can write A. What is A? The first term is 1 and 1 minus R. The common ratio is 1 upon 2. So I can write it that 1 upon 1 plus 2. Okay, and that is equal to less than 3. Therefore E is less than 3, and earlier we found that E is greater than 2. Therefore we can conclude that E, the value of E is always greater than 2 and less than 3. So I hope now you would be more familiar with E. Earlier many of you might not be very much clear with what does E exactly mean, and from here the concept of E comes. Now here I have tried to I have given you the exact definition that how E is derived in terms of a series, and then I also concluded that what will be the value of E, in which range the value of E will lie. So this video will prove to be beneficial, I hope so, because it will help you in clearing the concepts related to E. So don't forget to leave a comment and like the video. Thank you.